everyone, I am Minkle, Marketing Head at MoogleLabs, and it is with great pleasure that we host you today for the webinar Infrastructure as Code with Mr. Gagandeep Singh, DevOps Engineer at MoogleLabs. To start, I will take a few minutes to talk about our organization and explain the format of today's webinar. Focused by seasoned IT professionals, MoogleLabs specialize as accelerators and developers in future technologies to enable digital transformation. We are established in Canada and with our development centers in India and Australia. Our experts have helped several clients globally improve their business operations using AI, ML, DevOps, blockchain, data science, Web 3.0, and metaverse. If you need services in this niche, we would be happy to connect with you at an individual level to discuss the work in detail. As for the webinar, firstly, Mr. Gagandeep Singh will give a presentation on infrastructure as code on behalf of Moogle Labs and discuss its overall potential. The webinar will take around 30 to 45 minutes, then all the participants can take some time to ask industry specific questions. Please feel free to add your questions to the chat as they arise. The experts will address them at the end. Also, if you can please keep your screens on to see the presentation as a speaker goes through the various points. Now let's welcome our expert engineer to take over the screen.
Thank you, Minkle, for the brief introduction. Hi, everyone. Gagandeep this side from MoogleLabs. So basically, I'm DevOps engineer at MoogleLabs, having overall experience of 5 years. So today's agenda will be infrastructure as a code, as already Minkle has mentioned. And these are the contents that we'll go through this presentation. So first we will discuss about what is infrastructure, what is meant by infrastructure as code, why do we require it, applications of infrastructure as code, its advantages, approaches of writing infrastructure as code, when and how to use it, some tools and platforms. And at the end of the webinar, I will show you a code example of Terraform. So basically, it will be a code example there where we can learn how to implement infrastructure as a code, a basic implementation of infrastructure as a code. So move on to next slide. So we'll discuss about what is infrastructure. So basically, infrastructure refer to the physical and virtual components that support the delivery of technology services. Few example of infrastructure are computer hardware, software application, networking equipment, and data storage. And it is a major part of an organization because it enables the efficient and reliable operation of technology systems. A well-designed IT infrastructure can help organizations to reduce cost and increase efficiency and also improve security. It also enable the deployment of new technology and services uh, that are transforming that will transform the way business operate. And as you can see over the image here, so here you can see there are few components that I have presented. So there are servers, there are storage, network, security, and all these needs to be managed. And now we'll move on to our next slide. And guys, please let me know if I'm moving too fast. I can slow down my pace and you can understand easily. So, post your messages in the chat box. So now we'll move on to next slide. What is meant by infrastructure as a code? So first of all, we have learned that what is a basic infrastructure. So now what we is meant by infrastructure as code. So it is an approach to manage IT infrastructure in which everything is defined and managed through code. So basically we write uh, each and everything in code regarding to our infrastructure. Uh, there are IaC tools such as configuration management systems and automated deployment pipelines that enables the automation of infrastructure provisioning, manage it and updating it, and it also make infrastructure more scalable, flexible, and agile. And with the help of infrastructure as a code, developer and operation teams can work together more closely using the same tools and processes for managing both infra and application. It is an important concept in modern DevOps practices, and it has become a key enabler for organizations to rapidly and reliably deliver high quality technology services. So it is a most important part of our DevOps team that we are using infrastructure as a code. And all these things lead to IaC being integrated into CI/CD pipeline as an integral part of SDLC, that is software development lifecycle. Now we'll move on to our next slide. Sorry. So here I put on a chart, and as we can see here, from 2009 to 2021, you can see a rapid growth that enterprises are spending on cloud other than data centers. And as you can see, a growth of 37% compared to a previous year, that is 2020. And it's amounted at 178 billion US dollars. So as you can see, the trend is shifting from data centers to cloud. So this is also the main reason to use IaC in nowadays. So with the help of this bar chart, we can understand that why we have to use IaC. Now we'll move on to our next slide. Why did we require IaC? So basically, IaC was developed to address the challenges of managing IT infrastructure in modern, rapidly changing environments. It also provides a way to automate the provisioning of new infrastructure components, making it easier to scale up or scale down as needed. As we can see through as an example, when we are watching a match on Hotstar or any application, the users tend to rise up at a particular stage of a game. So it can also help to scale up the infra when user traffic is more, and also we can scale down as our needs. It also enables the rapid deployment of new infrastructure component that makes it easier to adapt to changing requirements. It ensures that infrastructure is consistent across all the environment, which reduces the risk of configuration error and make it easier to troubleshoot all the issues. IC tools also allow developer and operations team to work together more closely, using the same tools and processes for managing both application and infra, as we have already discussed this point in our previous slides as well. So IaC enables the automation of infrastructure provisioning, reducing the risk of human error. So with provisioning the infrastructure, we can eliminate or we can reduce the human error risk to below average. Uh, Now we'll move on to our next slide. So where we'll discuss about applications of infrastructure. So basically, IaC tools can help uh, to use to define provision cloud infrastructure resources as well as virtual machine storage and networking. So it will help in cloud infrastructure provisioning. It is also used to manage configuration software application running on infrastructure resources. This include installing and configuring packages, managing system configuration, and configuration application settings. And it also we can apply this in CI/CD, that is continuous integration and delivery. It is used to automate the deployment of infrastructure resources as a part of CI/CD pipeline. This enable faster and more reliable software delivery. And we can also use it in disaster recovery, where we can provision backup server, storage, and networking. And we can also use IaC uh, for our test environment provisioning. Uh, we can rapidly create and destroy test environment to test new features and releases that will be coming on our way. And it also helps in compliance and security. This includes defining enforcing security policies, auditing infrastructure configuration, and detecting the remediating security vulnerabilities. Now we'll move on to our next slide, that is advantages of infrastructure as a code. So basic advantages are it is faster and more reliable, uh, and it also allows our infrastructure to be deployed and managed more quickly, consistently, and reducing the risk of errors and downtime. It also allows developer and operation team to work together, as we have already discussed it, and it provide a greater scalability and flexibility. And you can up and down the scale as scale your infrastructure up and down as per our needs. And it also provide us more security, and it is easier it is easier to track and audit infrastructure changes, ensuring compliance with regulation and standards. It can reduce the cost associated with manual infrastructure management and minimize the risk of over provisioning. And it provide a greater consistency so that we can be on the same page when we are creating any infrastructure. And recover our uh, we can also recover our infrastructure from disaster by enabling the rapid deployment of new infrastructure components. Now we'll discuss about two approaches that will be needing to deploy an infrastructure as a code. So first approach is a declarative approach. It means telling your computer what you want your infrastructure to look like without worrying about how to get there. So we can take an basic example where you're telling your mom that you want a pizza for your dinner, and then she figure out how to make it. But you don't have to do anything because she will handle all the things to make a pizza. And you can say that what you want your computer to look like, and the computer does the work and make it happen. And to move on to our next approach, that is imperative approach. So it is a little different. So instead of telling your computer what you want to look like, you have to give it more detailed instructions on how to get there. So it's we can take a simple example of Legos, where you have a Lego set and you have few instruction to follow it, and to uh, building your Lego set. So in this case, you have to tell your computer how to set up each little piece of your infrastructure, and it takes a bit more time and work, but it can be more flexible and give you more control over how things are set up. So these are the basic example. So for declarative approach, you can use few tools that is Terraform, Pulumi, CloudFormation, Art, Puppet. All these tools are declarative. For imperative, you can use Chef. So we'll move on to our next slide. That is when and how to use infrastructure as a code. So it can be used in a variety of scenarios, including provisioning infrastructure, managing configuration, continuous delivery, and disaster recovery. And to use it, it is more important to follow the best practices, such as starting small and using a version control system, testing your code, and monitoring your infrastructure. And as you can see in the table I've provided here, there are few use cases and there are few tools also to use in that scenarios. If you want tools for only for your infrastructure management, then you can use Terraform, Pulumi, AWS CloudFormation as your resource template. And if you want control management with somewhat limited infrastructure management capabilities, then you can use Ansible, Chef, and Puppet. For only configuration management, you can use CF Engine. So now we'll move on to our next slide. That is different tools and IaC platforms. So there are few over here. And first of all, there is Terraform. It is an open source tool by HashiCorp that support both declarative and imperative IaC. It can be used with multiple cloud providers and support a wide range of resources, making it versatile and popular choice. And then we will move on to our AWS CloudFormation. So as you know, AWS is Amazon Web Services that allows you to define and deploy infrastructure resource using JSON or YAML templates. And it is tightly integrated with AWS services, and can be used to create, modify, and delete AWS resources. Then we'll move on to our third tool, that is Azure Resource Manager. Um, it is a service from Microsoft. uh, Microsoft Azure that allows you to define and deploy infrastructure resources using JSON templates. It is tightly basically integrated with Azure services only and provide built-in security and compliance features. Then we'll move on to Ansible, our fourth tool. Uh, it is an open source tool by Red Hat that support declarative IaC. It is designed to be easy to use and can be used to manage infrastructure or on premises or in the cloud. Then we'll move on to our fifth tool, that is Chef. It is an open source tool that support both declarative and imperative infrastructure as a code. It is designed for managing large, complex infrastructure and provide a lot of flexibility and control. Then our sixth tool will be the Puppet. Uh, it is also an open source tool that provides both declarative and imperative IaC. It is designed for managing infrastructure at scale and provide a lot of automation and reporting capabilities. So these are few example I've put on. So this is a Terraform code in JSON format, and this is AWS CloudFormation tool in YAML format. So there are few similarities and differences is over here. You can see that Terraform use AMI and CloudFormation use image ID to provide AMI to our code. And same, there are few similarities that as like instance type, where we have put our type of where we put the type of instance that we are using. And same goes for tags. Tags are used to provide a name for our resource that we are creating. So this is the few example. So, I'm done right now. Moving on to the conclusion that what we have studied over the slides. First, we have learned about what is infrastructure. Okay. So the basic of infrastructure is like infrastructure is a part. It is a different what you say, there are different things we can use in infrastructure, and it is the most important part of an organization. Then we have learned about what is infrastructure as code. So basically it is an approach that we use is to automate the infrastructure creation. Then we have learned about why do we need IaC. So it was developed to address the increasing complexity of infrastructure environment. Then we have learned about when and how to use it, and different we can use it in different scenarios. And also we have learned about application of infrastructure as code, how can we use it in different ways. And at last we learned about uh, some popular tools that we use for infrastructure as a code. Minkle, you can go ahead now, and then we can start a Q&A.
All right. Hello everyone, it's me again. Before we move to question answer round, I would like to take a few minutes of your time to talk about our company MoogleLabs for those who have joined a bit late. MoogleLabs is a brainchild of experienced IT professionals who work towards the digital transformation of the client's business operations using the latest technology like AI, ML, DevOps, blockchain, data science, and metaverse. Through this webinar, we aim to help others know the power of latest technology, and if you ever need an IT company that supports this technology, we would be happy to help you to decode innovation and improve your business efficiency. Now that's out of my way, Mr. Gagandeep can take over from here and answer the questions in the chat.
Uh, Thank you, Minchal. So first of all, I will show our demo code where where I can show our uh, joiners to take a look how it looks like. So as you can see over my screen, so this is a demo code for Terraform. So First, we are creating a VPC, that is virtual private cloud. So to use that, we are using resource block. So in resource block, we are providing AWS underscore VPC. That is a default thing. And this is a VPC variable that we are using. And this is a CIDR block where we are mentioning the CIDR block that we want to use. And these are tags, and I'm naming my VPC as my VPC. And this is internet gateway. So it should allow us to communicate to outside world. So again, we are using a resource block, and this is default we have to provide over here, that is AWS underscore internet gateway. And this should be mentioned by I have wrongly put over here that we as VPC, we can type it over here as internet gateway as well. And we are using a VPC ID that we have created over here. So this VPC ID is using over here. So, and we are providing it a tag as my internet gateway. And then we are creating a route table over here. It allows our subnet to access the internet through the internet gateway. And here again, we are using a resource block, and we are allowing outgoing access over here. So this is the VPC ID. It will be the same. This is the route we are providing over here. So 0.0.0/0 will provide outgoing access to us. And then we are providing a tag over here. Then in fourth section, we are creating our subnet. And this is the default for subnet. We are using same resource block over here. We are providing a CIDR block for our subnet, that is 10.0.0/24. Then we are providing the same VPC ID over here, and we are providing here availability zone. So there are different availability zone in AWS. So we are providing US East 1A, and this is the tag, and I have given the name is my subnet. And then we are associating our route table to subnet. And here we have again used the resource block, and this is subnet association. I've provided the name over here. This is subnet ID. So this is same that we have created over here. So that's why we are providing subnet ID over here as well. And this is route table ID. So this is what we are using over here, as you can see. Now we are creating our AWS instance. So this is again, we are using a resource block. This is AWS underscore instance, that is default. And I've put as in web, uh, and this is the AMI that is we are providing. So we can get our AMI from AWS. So if you go over here, if you click on launch instance, so this is the AWS console that we are using to get AMI. You can click on launch instance. Then you can go over here. So these are default uh, OS that Amazon provide. So I've used Ubuntu 20.04 server AMI. So basically you can see the AMI over here as well, and you can copy this AMI and you can paste it over here. So this is the same as you can see in this. And then we will assign a subnet to our AWS instance, and this is the tag I'm using for my AWS instance. Now moving on to our AWS console. So first of all, you can see there are no instance running, and there are uh, no instance over here as well. So now I will share my screen to how to run a Terraform .tf file. So this is our visual code, and here the code I've explained you, I have put it over here. So you can click on the terminal, and you can select new terminal over here. You can see my file, that main.tf is in users. Then this is my user ID, and this is my main.tf file. file. So we can cd into our user. Then we can run our first command, that is terraform init. Terraform init is nothing, it will initialize terraform at this location. Sorry, there is a typo. So as you can see, it is initializing terraform at the backend. So it has already initialized. Now we will run our next command, that is terraform plan. So terraform plan allows us to view what we have, what we wanted to create as per our file. So as you can see, there are few things over here. You can check uh, in this in Terraform plan. So it will show you everything that is creating, that it is creating. So we have already provided AMI, as you can see it, AMI ID over here. And this will these are the things that we can use, but we are not using it. So that's why it is written over here that it will apply it up. It will get these things after we apply the things. Then we will go to our next command, that is terraform apply. Apply dash that auto dash approve will do one thing. So if you'll only put terraform apply, we have to put the command yes, then it will go further. But if you'll put auto approve, we don't have to put any yes command over there. So now you can see it is creating a VPC first, as we have mentioned VPC. So we'll wait for a while it is making our resources. So as you can see, the apply is completed and it has created 6 resources. So we have provided 6 resources, as you can see. I have mentioned over here as well. So all the resources that we have provided in our main.tf file is already completed. Now I'll move on to our AWS console and show you. I will refresh this page and I'll go to this EC2 console. And you can see there is one instance that is running. So as you can see, we have provided the name first instance that is running over here already. So basically right now it is initializing. And now I will go to VPC section and I'll show you what we have created in our VPC section. So as you can see, there are two VPCs. So one is default and one that we have created. So as you can see, there is my VPC that we have created right now. And this is the name that we have provided. And also if we go to subnet section, this is the subnet. So this is the subnet that is created over our AWS console as well. And if you go to route table as well, same will be populated over here as well. And if you go to internet gateways, you can see the internet gateway as well. So VPC, subnet, route table, and internet gateway is done. And also we have seen our instance. And the sixth part was uh, route table association. So uh, we can see that as well. So if we want to check our association, we will go to subnet and we can see route table over here. So this is the internet gateway that we have provided. So as you can see, uh, this was our internet gateway and this was our route table and this was the CIDR block that we have given over here. and this was the routable association. So we can see it in this routes that the both are already present over here. So all the six resources I've shown you that we have created through Terraform main.tf file, the basic creation of a Terraform instance through Terraform. So now I'm open for questions. So I will stop sharing my screen. And if you have any doubts, you guys can ask. So we got our first question from Arijit. Thank you, Arijit, for asking. So a thing, basic difference between data and variable in Terraform are data sources provide dynamic information about entities that are not managed by current Terraform and configuration, and variable provide static information. We can use dot var file, and we can use the variables in our main TF file as well. So I got one more question, the difference between Terraform, AWS, CloudFormation, and ARM templates. So basic difference between is AWS CloudFormation use, or we can use it only for AWS instances or AWS infrastructure. And same goes for Azure. We can use Azure template for creating Azure infrastructure. But Terraform is something different from them. We can use all three major cloud providers, that is GCP, AWS, and Azure. We can create infrastructure from Terraform for all these three major cloud providers. We got our next question as well. So, what is the use of TF state file in Terraform? So, basically, TF state is used by Terraform to map real world resources. So, for your configuration, and you can keep track of metadata and to improve performance of large infrastructure as well. So you can use TF state file over Terraform Cloud as well. If you have your TF state file saved with you, you can use it on Terraform Cloud that provide. And the main purpose of TF state file is you can have same infrastructure if you have already deleted it from your system. So if you have a TF state file, you can create it on Terraform Cloud or anywhere. So basically, it is used for metadata.
The next session from MoogleLabs will be on ML recommendation engine by Atirek and Nikhil. Please drop your email address in the chat and we will keep you posted about the latest events. Also, if anyone needs presentation, please drop your email in the chat and we will send you as soon as possible. Thank you so much everyone for joining us.
Thank you, everyone. Thank you for joining.